All right, guys, this is going to be the second part or the 8.2 video. The second video of three, I think, in this section. So we're going to talk about the four steps. I want to do this in class together, so we can spend some time, ask questions, kind of go over it together. You kind of see the whole four-step process again, but it's pretty useful. Like I said, we're going to use this four-step process a lot between now and the end of the semester. So we'll kind of go through this together as a class. But what we can do is talk about the second part of 8.2, which is estimating sample size. And so I told you guys in the first part of the video, or in the first video on 8.1, that our confidence interval is equal to our point estimate plus or minus the margin of error, right? And we said that margin of error, ME, is equal to your test statistic times your standard deviation. All right. And so what we need to do is, so now how do you choose a value for p hat when solving for sample size? What you're going to do is you're going to use a guess for p hat based on a pilot, study, or any past experiences. All right. And so I've talked about this test statistic a little bit, or this critical value, what they call it sometimes. And basically what you have is a z-score, it just represents a z-score that represents a certain percentile. So what you're going to do, and we'll look at this in class, is basically on the inside of your table, right, it kind of represents percentiles, percentages, and you can find a corresponding z-score that represents a certain percentile that we're looking for. Okay, so for example, in the next one, if we want to do a 98% confidence interval, I can tell you that the z critical value, or your test statistic, so I'm going to call it z star, that's what we do, we write z star, is equal to 2.33. Okay. Now, what I want you to do is when I find this value, right, if you think about it, here's your distribution. Okay. And we want a confidence interval 98%, so that means we want 98% here. Right, we want this interval to represent 98% of our data. So that means that we have to have 1% over here. This is 1%, and this is also on the other side 1%. And when we look in the chart, though, when we look at our z table, right, what you notice is that you have it gives you the probability of everything below. So if we want to find this 98% confidence interval, I need to find the critical value of this. Right? I need to find this spot on the graph, right? Because that will give me the rest of it in the middle over here. So that's kind of what you have to do. You have to look at, okay, well, what's the cutoff value going to be? And then I'm going to use that to find my corresponding critical value. Okay, so that's kind of where that comes from. So 2.33 is that value. And again, we'll look at that more in detail in class for sure. So now all this is just is a bunch of algebra, which, so if you're really good at algebra, you're gonna find this fairly easy. Otherwise, it can be just a little tricky in terms of, so z equals z critical was 2.33. Just gonna rewrite this. Need a little more room. All right. So we know from our margin of error equation is equal to your z critical, your test statistic times your standard deviation. And because we're looking at proportions, we know that this is the same thing as p hat times 1 minus p hat over n square root. This is from earlier. And so what we're trying to do is we're trying to solve for n here, right? We know margin of error. If you look in the question, we know all this stuff at the top. We just need to solve for n. Well, now we're just trying to do some algebra, right? So think about what we can do in order to make this happen, right? So again, we're trying to get n by itself. So the first thing I can do is I can divide by the critical value on both sides. So we have ME over Z star. And that's going to equal this whole thing on the right hand side. So P1 minus P over N. Okay. Now I can square this whole thing to get rid of the square root. And if I square the other side, so then I get ME over Z critical squared is equal to, and now the square root is gone, so I just have P and then 1 minus P over N. If I multiply by N on both sides and then divide by the thing on the left-hand side, I can just do this step by step. So then you have N times, if I multiply by N on both sides, ME over Z critical squared is equal to P times 1 minus P. Now we got to divide by this whole term on in the front, divide by ME over Z critical squared. These cancel, divide both sides, and you just solve for N. So just a bunch of algebra here just to get to this point. So this is kind of our equation now. And now we're just plugging in information, right? So if we're assuming that, so we're looking at, let's say 50% of people have a tattoo and 50% don't have a tattoo. Then I'm going to start plugging in my information. Okay, so then you can plug in, and we know the margin of error here is 0.1, right? We know our Z critical, we found that earlier. So I'm just plugging everything in. So then you have 0.5 times 0.5 over 2.33 over, oops, sorry, 0.1 over 2.33. Margin of error, 0.1 over 2.33. And now you're just going to your calculator from here and squaring this. Right? And once you simplify that down, you'll get N equals 135.7. We always round up, so we say that N is equal to 136. Okay? So make sure you always round up. So just a bunch of algebra just to get to this point, and then you kind of just plug in information from there. All right, so what are the conditions you got to check for confidence intervals? So the first one is random. So the data were produced by a well-designed random sample or experiment. And we still have the 10% condition, right? That's your independence condition. This can be one of the hardest things about this class, is just memorizing or remembering what conditions to check when. So N has to be less than or equal to 1/10 big N. And then for proportion, we had to do the normality check, which is N times P has to be greater than 10, and N times 1 minus P needs to be greater than 10. All right, so this was your normality check. Because we can only use that Z critical value that I found up above if we have a normal distribution. If it's not normal, then we can't really say much about it. Okay, so now go to the next question. What is the difference between standard deviation of a statistic and standard error of a statistic? So when the standard deviation for a statistic is estimated from data, the result is called a standard error. statistic. So this is the shift, and we're going to talk about a new distribution now from the Z table to the T table. Okay, so Z is when you know known population standard deviation. So then we reference this with the standard deviation of statistic, right? And then we have T, which is equal to estimated standard deviation from sample. This is called your standard error. So here I can write a couple of equations down. So your standard deviation of your proportions, again, we're looking at just proportions, so all percentages for right now. We have P times Q over N square rooted. Okay, it's your standard error. So again, if we're estimating this now based on some sample, which is kind of more likely, okay, again, we use our sample notation. So we have P hat times Q hat over N. So same equation, just using different values. This is a times sign there. Right, so here I can write SE describes how close the sample proportion P hat will typically be to the population proportion P in repeated SRS of size N. Okay. Is it okay to use your calculator? Yes. Again, we kind of talked about this. You kind of need to set it up, and then once you set it up, and I'll go over the calculator stuff in class. But let me just write something down so you kind of have this in your notes. So in your calculator, you're going to go menu, statistics, and then confidence intervals are there. So again, we will look at this problem below together in class together. That way you guys can ask questions. But that's kind of, again, just kind of some Spark Notes version of some notes here. So we'll look at this problem in class. And then again, we'll do this activity in class too. You can check it out yourself. Little website here. Take a look at what happens when you press some different types of sampling. So you kind of see what happens here. We'll look at this again. We'll look at this website together as well, but take a look at it for yourself. It is pretty interesting. It'll help you kind of get used to some of these ideas. A bunch of steps here and what to do. But we'll look at that together in class. So we'll kind of look at this. And that's it for this video. And we got one more video coming up on 8.3, which is confidence intervals for the mean. But that will be that. So again, as always, if you have questions, let me know. But if not, have a great rest of your day.